Derivatives with exponentials, quotient rule, Leibniz's notation. So, here we have a to the power of x, a function, and when we want to derive that function, we get ln of a multiplied by a to the power of x. Think of a as just a number. So, if you had 7 to the power of x, the derivative would be ln of 7 multiplied by 7 to the power of x. Here is the quotient rule. We have a function over a function, u over v. When we derive y, we get v multiplied by the derivative of u minus u multiplied by the derivative of v all over v squared. This is the majority of the focus for this tutorial. Let's start with an example. Say you have y equals 5 to the power of x over x to the power of 3. We have our function over our other function. Say u equals 5 to the power of x and v equals x to the power of 3. Now we've done labeling them, let's write out the formula or the equation for the quotient rule. We have v multiplied by the derivative of u minus u multiplied by the derivative of v all over v squared. Let's find the derivative of u and the derivative of v so we can finish this question. The derivative of u is 5 to the power of x, so like before, when we derive that, we have ln of 5 multiplied by 5 to the power of x. We have our number to the power of x. When we derive that, we get ln of the number multiplied by the number to the power of x. V being x to the power of 3, derivative of v is just 3x squared. Filling this in, we get v x to the power of 3 multiplied by the derivative of u ln 5 multiplied by 5 to the power of x minus u 5 to the power of x multiplied by the derivative of v with respect to x, which is 3x squared all over v squared, v being x to the power of 3 squared. If we were to expand the bottom brackets out, we would get, just rewriting the top, we would have x to the power of 6, because we have an x to the power of 3 and an x to the power of 2, we can use the x to the power of 6 to eliminate some of these. Because x to the power of 2 has the smallest power, we'll get rid of that altogether and we'll take 2 of each. So that'll be now 4 and that will be 1. I'll rewrite that so you can understand a bit better if you can't. Let's say we have x ln 5 multiplied by 5x to the power of x minus 5 to the power of x multiplied by 3 all over x to the power of 4. What I've done here is just taken 2 off the x, that will make it 0, I've taken 2 off the 3, making it 1, and I've taken 2 off the 6, making it 4. We can simplify it even further. By factoring out the 5 to the power of x. Because we have 5 to the power of x multiplied on both sides of the minus sign, we can bring it out the front. And that there is our first derivative of this function up here. Let's do a second example. Say we have y equals sine x over 10 to the power of x. We have our function over our other function. So we'll label u as sine x, and we'll label our v as 10 to the power of x. The derivative is v multiplied by the derivative of u with respect to x minus u multiplied by the derivative of v with respect to x all over v squared. So we need to find the derivative of u, and we need to find the derivative of v. The derivative of sine, just cosine, and the derivative of 10 to the power of x, just like before, number to the power of x, equals that ln. When you derive it, equals the ln of that number multiplied by that number to the power of x. In this case it's 10, so it's ln 10 times 10 to the power of x. If we fill this in, we get 10 to the power of x being v multiplied by the derivative of u cosine of x minus u sine x multiplied by the derivative of v ln 10 multiplied by 10 to the power of x all over v squared being 10 to the power of x squared. So, if we were to simplify this further, we could factor out, because we have a 10 to the power of x on both sides of the minus, on top we can factor that out and bring it out to the front. And now we can cancel it off, cancel off the 2 on the bottom. Simplifying it further, rewriting it as well, we get the derivative of y with respect to x equals cosine x minus sine x ln of 10 all over 10 to the power of x. And that is our first derivative of this up here. For our third example, so we have y equals 8 to the power of x over e to the power of x. We have our function over another function. So we'll label u as 8 to the power of x, and we'll label v as e to the power of x. Derivative of y with respect to u is v multiplied by the derivative of u with respect to x minus u multiplied by the derivative of v with respect to x all over v squared. In order to complete that, we need the derivative of u, and we need the derivative of v. The derivative of 8 to the power of x is ln of 8 to the power multiplied by 8 to the power of x, just like before. Number to the power of x when you derive that, equals ln of that number multiplied by that number to the power of x. When you derive e to the power of x, that's just e to the power of x. I won't go into detail on that. I have a video on that, but I won't go into detail on it here. So if we fill this in, v is e to the power of x. We multiply that by the derivative of u, which is ln of 8 multiplied by 8 to the power of x, minus u, which is 8 to the power of x, multiplied by the derivative of v, which is e to the power of x, all over v squared, which is e to the power of x squared. If we were to factor these, because we have an e to the power of x and an 8 to the power of x on either side, multiplied to either side of the minus, we can factor them out. Giving us e to the power of x multiplied by 8 to the power of x, bracket ln of 8 minus 1, all over ex squared. Now we can take it a step further, cancel off the squared, cancel off the ex, e to the power of x, and what we'd end up with is 8 to the power of x, bracket ln of 8 minus 1, bracket e to the power of x. And that is the derivative of this function up here, first derivative. Thanks for watching. I hope this helped.